Hello everyone, welcome to AI Anytime channel. In this video, we are going to look at LCM LoRa. Okay, so in this tutorial, we're gonna use LCM LoRa with SDXL, Stable Diffusion XL. In only 4 steps, we're gonna generate images. Okay, so if you don't know what LCM LoRa is, I will explain that theoretically, and also we'll see that how we can use the code to generate images with only 4 to 5 steps. So LCM is an acronym for Latent Consistency Model, and you can see the research paper over here. It says Universal Stable Diffusion Acceleration Module, right? So it accelerates basically, your image generation task. Now, latent latent consistency model is a method that reduces the number of steps required to generate images, and they do it by distilling the original model into a separate model. Now, the if you have worked with stable diffusion and the diffusion models like SDXL, etc., they used to take 25 to 50 steps. Now, but with the help of LCM LoRa, it can be done, in 4 to 8 steps. That's the agenda of this video. Now, the distilled models may be designed to be smaller as well. In this case, it can be DistilBERT, it can be Whisper, etc., etc. You know, now this typically requires, right, huge amount of data, a patience, a few GPUs as well. And earlier it was time consuming, expensive, but that's all in the past, right? Now we have LCM LoRa, which is a very recent kind of it's been established recently, I think in this month, in the November 2023, and it's a new method that speeds up the stable diffusion and SDXL, uh, and it runs basically 7 to 8x faster on the GPUs that we use, basically 3090. And even if you are using Mac, it is even more faster. On Mac you will get a 10x speed up on this. Now, I hope you would have heard about the word LoRa at least, right? So the core idea of LCM LoRa is to learn only a small number of adapters. That's basically your LoRa layers instead of a complete model. Now, the resulting LoRa can be applied to the fine-tuned model without having to extract it separately. So there are different steps to learn, your own LoRa. Maybe, for example, I can just, write it down over here. Let me see, if I can explain that. Okay. So first thing is that you select a model. So select a model from the hub. Select a teacher model rather. Okay. From the Hugging Face hub. So I'll just write from the HF hub. Now the next step is, for example, you can use SDXL over here. So let's, for example, see SDXL, the base model, or fine-tuned. We have a lot of fine-tuned dream booth model as well, right? We have a lot of dream booth fine-tuned models that can be used as well here. Now that's the one part. Now second step is gonna be learn learn LCM LoRa on the model. And the third step is that you use LoRa, the low rank adapters, with any SDXL and the LCM scheduler. Okay, so and that's what we're gonna look at as well shortly. Okay, so use LoRa with any SDXL and LCM scheduler. That's the method we're gonna look as well in this video, right? So these are the steps, right? So to learn your own LoRa, so 3 steps that we have categorized here on very high level, but this you can read in the paper. I just got these inferences and findings from this research paper. I'll give the link in the description, but it's very famous. You just go and write LCM LoRa on the internet, and you will probably get this research paper over here. Now, so how can we do a high speed inference using LCM LoRa, guys? Okay, so it can be usually used in the diffusers library. Okay, so if you are not aware about diffusers, let me just show you diffusers, the GitHub, right? So once you write it, and you will find out the state-of-the-art diffusion diffusers model over here, right? This is the GitHub repository for diffusers, and we're gonna use diffusers basically to perform the inferencing, high-speed inferencing using LCM LoRa. Now let's come back, here, and you can see I'm on my Colab notebook, and I have my GPU on. So let me just do an import torch, and what I'm going to do next is from diffusers import diffusion. No, not diffuse. I think it's diffusion pipeline. Yes, correct. And the LCM scheduler. Okay, so let's use that. LCM scheduler. Okay, it might give you an error. It will say that no module name diffuser. So what you have to do in that case, you have to come over here and you can just do, install diffuser. So let's come back, put it over here, Control V, and let's just install. Okay, and this will install diffuser. And once it installs, then you can just okay. Now we have imported the dependencies that we need. Now we need a model ID, right? We're gonna use a model here. So let's define a model ID, and I'm gonna go on Stability AI Hugging Face. So let me just search Stability AI HF, and I'll just hit enter, and it will take me to the Stability AI. Okay, I'm just looking for their to uh, I'm just looking for their diffuse stable diffusion XL base. Uh, Okay, this is the model that I'm looking for. We can use this model. So let me just copy this here, and I'll just paste it over here. Now this is the model that we're going to use, stable diffusion XL base 1 point, the first one, okay, the first version of it, and then LCM LoRa ID. So let's define a variable called LCM LoRa ID, and here I'm going to use from latent consistency. Okay, that's the, I hope I spelled it right. A latent consistency. And I'm going to use their SDXL LoRa. So LCM LoRa SDXL. This is the repository that we're going to use. LCM LoRa SDXL latent consistency. I hope I spelled it right. Now let's have a pipeline. So I'm going to have a pipe, and we're going to use diffusion pipeline. So diffusion pipeline dot from pre-trained, which is model ID, which is right, and let's use the floating point 16 variant of this model. Okay, so when we are loading it, so variant, and I'm going to use FV16. Okay, we have a model ID, and now let's run this. It will take a bit of time, to load the model thingy. You can see that it's loading around 5.1 GB model weights, and here 1.39. So right, this model weights will get fetched from the Hugging Face repository through diffusion pipeline. And let's write the next bit of code. Now once we have the pipeline, what we're going to do is we're going to load the LoRa weights. So for that, we're going to say load uh, LoRa weights. Yes, so we're gonna use now this function, which is low rank adapters weights, and here we're gonna pass the LoRa ID, and you can see now we have our around 394 million parameters of shape tensors, of format, and now we have loaded our LoRa weights. Now the next is the LCM scheduler, right? So for that, to from config, this looks nice, right? I think generative AI is doing great things within Colab, right? So the recommendations are really good. Now we have imported here LCM scheduler. You can see it over here, and then we have dot from config, and in that, what we are doing is that we are saying, okay, we have a uh, pipe scheduler config that we're gonna use. So let's do that. Okay, so we have LCM scheduler dot from config pipe scheduler config. Okay, Now, what I want to do next is let's pipe it to CUDA so it utilizes your GPU. So pipe to and then device, and then I'm going to pass CUDA here to use the CUDA kernels, and then the data type of this is going to be the floating point 16. So torch float 16, that is right. Let's do that. And you can see it has been done successfully. Now let's define a prompt here, guys. So what I'm going to do is let's have a prompt. For that we're going to generate the image. So for that, a close up photography of an old man standing in the rain at night uh, in a street lighted by street light by lamps or something. Let's write it like that. Okay. And maybe we can use some uh, parameters, some arguments, or some features of camera, etc. So let's do that. Okay. And you can try with different prompts. Now this is my prompt, okay, that I'm going to generate the image for. Now I'm going to write a variable called images, and I'm going to use the pipeline. So pipe, the variable that we have. Now within pipe, the first thing is prompt equals prompt. So let's do that. So prompt equals prompt. You can also pass number of inference steps. Like you can see, it suggests 50, but we're gonna not do 50. Let's do 5 or something and see what it does, right? And that's why we are using this. Now we have a guidance scale. I'll prefer keeping it 1. Okay, for this, let's do it 1. Now, uh, okay, let me just remove this part. We do not need it here, so let me just remove this. Now we have a guidance scale, that is fine. Now let's, you can also set height, etc., but it's fine. Let's keep images the first one, so to get the first image out of it. Now the images, and then images pipe prompt equals prompt, number of inference steps 5, guidance scale 1, images 0. Now let's see if we get anything here. Okay, image object is not subscriptable, fine. Okay. If you see it over here, right, we got a very good image, by the way, guys. On a very basic prompt that can be, and you can see that how fast it is, right? Instead of you're waiting for 30 or 50 steps on a number of inference steps, just by passing 5 steps, we get a good quality image. Okay, if you, I'll just do a save image as in my pictures, and I'll just save it, and let's open it in. Okay, it's downloading. It's a little big as well. Okay, and now see the quality of image that we have got, right? It's fantastic, the image that we have got. Now, so in this case, now what we did here, guys, the steps that we have seen when we have used this inference code over here. If you look at all of this code, let me just put it over here so you can find it out. Now, the steps that we have followed here are like, the first is steps for inference or generation rather. Now, steps for generation, the first thing is the diffusion pipeline. Because we can use it through diffusion, you can also use it through transformer pipeline if there is any compatibility. Now, diffusion pipeline using SDXL base, that's what we have done first thing first. SDXL base, and then we applied LCM LoRa over here. So let's just write LCM LoRa, and then we change the scheduler to LCM scheduler. So change scheduler to LCM scheduler. This is a step that we saw, and just in the 5 steps we got this. Only in 5 steps we have got this fantastic image, and this will help you when it comes to efficiency and feasibility of these models, right? Also, because when I say about the feasibility, you do not need that a hell lot of compute power, and also latency is a challenge, right? In that case, because you have to wait for 50 steps, for example. You don't have to do that. Now, uh, we can do some kind of greed. We can look at the progression as well. I don't know if I have time to do that, but in this video might become lengthy, but let's try it out a few things. Compare the steps and see that what is the uh, standard steps that LCM LoRa can generate a set of images or an image of good quality. So I'm going to have an empty list of images, and let's just going to use 4 steps in range, and let's keep 8, for example. So we're going to evaluate it from steps 1 to 8. And for this case, okay, let me just do a generator. So generator equals torch dot generator. Okay, I think it's capital. Why it's not suggesting generator device, and I'm gonna use pipe dot device here. So we have pipe, which is our variable pipe dot device, and I'm gonna set a manual seed here. So manual underscore seed, and which is, let's for example keep a higher seed here. So let's keep a seed for reproducibility, and then I'm gonna have an image variable image equals pipe, and I'm just gonna uh, pass my prompt equals prompt. Then I'm going to pass my number of inference steps equals, let's have, then it will not be steps, then it will become, we have range, it will become steps plus 1, right? And then guidance scale equals 1, generator equals generator, images 2, we do not need this one, and then images dot append. Yeah, this looks nice, and let's see, let's run it out and see. Okay, so it's generating, this from steps 1 to 8, and just want to see that, uh, like, just want to find out on the steps 1 and on the steps 8 throughout these steps, what are the standard that we can recommend when we are working with this kind of methods like LCM LoRa, for example, the latent consistency model. Okay, so this is what is interesting, right? So let's find it out and see. When we can also compare with or without LCM LoRa, and I will leave that up to you. You can find it out, without LCM LoRa as well. Now let's do images, and you can. So we have to use PIL here, pillow, because we have a number of images. Now you can see on the images, the first one, the first image that we are. But you can look at the uh, generation steps, right? On the first step we are not getting anything. It looks like, it really looks horrible, by the way. Okay, I'll just make uh, so the first one and see how much it improves. You can see now it improves, right? It has some textures. Okay, so it gets some textures into the image that we have generated. So now let me jump into the steps 4, which what they recommend, right? 4 to 8, that's in their research paper. Now let's look at the 4, because earlier we printed out for 5. Now let's look at for 4 and see what are we getting here, for 4. And you can see the 4 for now we have a very dashing image, very look at the swag that the guy is carrying, right? So this is the images steps 4, and which is really good. Now let me just look at the 8 and see what we get here on the 8. It says list index out of range. Okay, which would be 7, because we have it should start from 0 to 7. That's how the indexes are, right, for the list. Now for the list element, now let's find it out for the last steps and see, and you can find out how clear this image is. This really really fantastic, and it took us less than uh, even 5 to 10 seconds, for all of this 8 steps. Now, if you're running it for 5 steps, it will probably take you 5 steps on T4 on Google Colab. Now imagine if you deploy this on the hyperscalers, like for example, if you're using AWS SageMaker or Azure ML or GCP Vertex AI, you deploy this for your clients where you are working with image generation steps. So you can basically cut down the cost as well when it comes from the feasibility standpoint. So you do not have to rely on the heavy compute power, because in that case, latency will not be a problem. So do not have to wait for like 50 generation steps. You can do it for only five number of steps, right? You can. That also has an option of, you know, uh, let me just write it down for you quickly, but you can go through the research paper. But I will put it something that I can recall. Uh, Few info here. The info can be, the first thing that you can focus is on the guidance scale, which is very important. So on the guidance scale here, uh, basically which disables the guide scale. The value is from 1 to 2, okay, of guidance scale. Okay, if I am not wrong, if I recall it correctly. Now this, so the one works well for most prompts and is the fastest, but if you can also set negative prompts, okay, but if you put guidance scale equal to 1, negative prompts are ignored. Okay, and you can also generate images using negative prompt by specifying a guidance scale between 1 and 2. Okay, now I think it's not 1 to 2, right? I cannot recall it correctly. I think from 0 to 2, but in the uh, if if it's from 0 to 1, I think then in that case, uh, negative prompts are ignored. Negative prompts are ignored, and if it is 1 to 2, then you can use negative prompt, but that will be a bit slower and bit slower. So this is very important when it comes to the guiding scale. You should know that. And so I haven't seen value larger than 2, but if you can find it out, please let us know in the comment box. Now, this is on the guidance scale, which is one of the inference parameter for this particular LCM method that we're going to use. Now, you can also compare with and without LCM LoRa. Now, if you have an SDXL base, which is without LCM LoRa, you can revert uh, like you can also unload the LoRa weights, by the way. Okay, you can also just do, pipe dot, there's a method called unload. If I'm not wrong, it's unload. Yeah, you can see you can also unload the LoRa weights. Okay, and so right now here we are using LCM scheduler, right? But in that case, you cannot use LCM scheduler if you want to compare this with and without LCM. So for that, you can use Euler, for example. So you can use Euler discrete scheduler or something like that. Now, here if you have pipe unload LoRa weights, we'll just put it over here, and then you can just do it yourself. So maybe I'll share you the notebook. You can find it out on my GitHub repository, and you can do it yourself. So you can just unload, and let me just see. Okay, you can unload. I can have a look here. So pipe dot unload LoRa weights. Then you can just do pipe dot scheduler. If I can recall correctly, I have to load that, right? So let me just do an import here. So what I'm going to do is from diffusers import, what was that? Euler, correct. Euler discrete scheduler. Now here, what you can do is you can just define an Euler. So Euler discrete pipe scheduler config, and you just do this. Once you do it, you can find it out over here. Now again, you can use the inference with number of steps, right? You can do uh, define it like the same function that you can use, the ever function that you have used over here, but it will take a bit of time. So let me just give you the code so you can try it out. Now just copy this from here and come down, and here just paste it down. Now in this case, for steps in range 8, right, you cannot give range 8 to do a comparison. So in that case, what you have to do, you have to set a groupism, right, of this step. So for example, let's keep 25, 30, and then keep 50 or something like that, right, for 50 generation steps. Now uh, Generator looks fine, device, manual seed, keep the same, image pipe, prompt, negative, number of inference, steps, just keep steps, you do not have to do one here because that already has been set. Now steps, generator equal to generator, you do not need a guidance scale here for in this case, so just let's remove guidance scale. Now you have images, to images dot append images. Now you can use this piece of code to run it. It will take a bit of time, so I'm not running it, but I will just add a few more cell and text here that what kind of models are available. Okay, so in the LCM LoRa thingy. Okay, so collection, and here we have a lot of models. The first is LCM LoRa SDXL that we have used in this tutorial. Okay, then you have a lot of other as well, guys. You have HD, what is that, V15 or something like that, right? You also have that 1.5, if I'm not wrong, that you can use. You can also use, and that's also I'm gonna try here, guys. I think that will even be more faster if you combine LCM LoRa with SSD. I also have created a SSD video, okay, very recently on my channel. Please check it out, which makes it really faster, which is by Segmind Stable Diffusion. So Segmind Stable Diffusion combined with LCM LoRa will make it even more faster. So these are the few models that are available on this LCM LoRa collection. Now, uh, you can try it out. You can run it. I don't know if it's gonna work, but you can try it out yourself. It says range expected at most 3, got 7 or something like that, right? So you can check it out. Okay, for steps in. Okay. It will not be range anymore, right? Because that has been for steps in 14815, and you can see it out, right? It's generating the images and all that. So for all of these steps, and of course, it will not be that faster, as you can see, but you can test it out and let me know your findings on this. Okay, and let's see if it gets done, guys. Maybe we can just have a look quickly. I don't think so. I think it will take a bit time, but we can wait for it and at which we'll just see on. So this is on 8 step with LCM latent consistency model with LCM scheduler. We'll just evaluate on the same, okay, on the 8 steps. Okay, we have an 8 steps here, so we'll just evaluate. Let's wait for it. So we are on 25 steps. I'm just gonna do here images thingy here as 7 or something, and let's find it out, okay, in a bit. Okay, you can see it's gonna take up time, but the good thing about LCM is that just only in 4 to 5 steps you can get your a very decent results. Okay, and please go through the research paper, which is really, I really like the paper. I read it. There are good learnings from this paper as well. There are some great things going on, guys, and you can see I'm really big fan of SSD, segment stable diffusion. You can find out the quality when you use LCM LoRa together with SSD. That I will definitely recommend even in production. If you want to deploy this combination, you can configure this further. Really looks nice. Just see the quality of it, right, which is fantastic. Now look at this image, which is so real. And even if you look at the unrealistic images, for example this one, that's really cool. And this is a scenic image. You can look at this black and white image over here, and you can just read this research paper, which is only 7 pages, and you can use one of your previous experiences of stable diffusion as well to derive some findings. Now let's see. It's just gonna complete the 50 steps. Okay, so let's wait for it. And you can see that we are done with our image generation steps. I'm just gonna do list index out of range. Okay. I'm doing such a stupid mistake, right? Because these are the indexes will start from 0, 1, 2. So if you look at the this is really a stupid mistake. If you have to look at the 8 step, right? This will be your 0, 1, and 2. It will be your second index out of this list element. So when you have to do images 2, and probably then you will see your image, right? So and then we compare this, because this is of when we are using LCM LoRa with low rank adapters of latent consistency model, we get this image on the 8 steps. Okay, now the same 8 steps, which is the third out of this index of list, we are getting this image, which is not at all good, right? When you compare with this above image that we have over here. Now let's find it out for the same. So we have 7, right? So it will not be 7. I was doing a mistake. If you want to look at the last image, that will be 6, because the indexes will start from 0. So if you want to find out the image quality on the 50th steps, we have to do at images of 6, and then you can find out a decent image, which is of course better than the on the 8th step that we saw using without LCM LoRa. But again, I loved this image more because the prompt is still same, and you can find out that LCM LoRa really also improves the textures, the quality, and the image quality as well altogether. So that's all right. It's fantastic. It's a great learning. I loved it. I have a video on SSD as well, Segmind, and now we have a video on this as well, LCM LoRa, and we also have couple of other videos on stable diffusion SDXL. So we have now good amount of videos on image generation apart from Mid Journey DALI, that that's there, right? So please go through the research paper. This notebook will be available on my GitHub repository. You can find it out, and maybe you can build a Gradio application, or an application that you can run it, or you can deploy it as well. Now, if you like the video, please hit the like icon, guys. And if you like the content I'm creating, please subscribe the channel if you haven't subscribed in that case. And please share the video and the channel with your friends and to peer. If you have any feedback or thoughts, please let me know in the comment box. You can also reach out to me through my social media channel. Please find those on my YouTube channel banner and the channel about us. That's all for this video, guys. Thank you so much for watching. See you in the next one.